Hello, everyone, and thank you for tuning in for today's webinar in partnership with Pure Storage. Today, we have a fun and interactive session for you. Our topic today is simplifying and improving high availability and disaster recovery for SQL Server with Pure. My name is Eric Romero from PassHQ, and I'll be your co-host and moderator alongside with Melody Zacharias from Pure Storage. She'll be behind the scenes, making sure the bingo game is running smoothly. Before we get started today, I'd like to go over a few items in housekeeping so you know how to participate in today's session. Remember that the recording of this webinar will be provided to you after in a few days. You'll receive an email letting you know once it becomes available. We would also like to hear from you with any questions you may have during the presentation. Make sure to use the chat box in the control panel to get in touch with us. Argenis, next slide, please. Also, throughout the session, I will read your questions aloud to our speaker. And at the end, we will have some time to address any remaining questions. Remember that your feedback is really important for our presenter and for us for future webinars. So please, we ask you to fill out the survey that will pop up automatically in your web browser after the session ends. Next, please. Now, on to the good stuff. If you're here to just learn and watch the presentation and you're not interested in playing, that is completely fine. Just sit back and enjoy the session. But if you want to play along while you learn, you must complete the opt-in form to get to your bingo card. Many of you have received an email from Carol and have their cards already. But for those who do not have one, head over to the registration link and fill out the opt-in form. Once completed, you'll receive an email from Carol with your card. For those who are partaking in today's session, you will be playing to win one of the 10 prize packages sponsored by Pure Storage. Each package contains one Timbuktu backpack, one Corksicle tumbler, a Pure Storage branded hat, and a reusable straw. Now, and while we give a little chance to those who are missing their card, I'd like to remind you that you can now unlock exclusive training, discounts, and networking sessions when you upgrade to Pass Pro. Don't miss out and upgrade your Pass membership today. On to the rules for today's bingo. For those who just opted in, you should have an email in your inbox from Carol, here's your bingo card, within the next few minutes. If you still haven't received this yet, please let us know and we'll try to get this over to you as soon as possible. In order to win, all the squares in your bingo card should be covered and completed with pure stamps to have a bingo card, a valid bingo card. You will have to pay close attention to the slides throughout the session. How do you collect pure stamps? In your card, you have different words and phrases which can be in any column or row. When you see any of these words or phrases in the presentation slides, click on the square to place a pure stamp. Although the speaker might mention some of these words or phrases, we will only tally those that appear in the presentation. Remember, these words or phrases must be seen in the slides. When your card is completed, send us your code, send us the code of your card through the chat box. You can find this code in the URL bar. It would be something like this. Please look at the chat box. After the pound sign, those numbers, that will be the number of your bingo card. Once we've verified that your card has a valid bingo, Pure Storage will be notifying those who submitted their cards first. Remember, we have 10 prize packages to give away today. And on to our speaker today. He is the principal architect at Pure Storage and is based in Seattle. He's also a former data platform MVP and VMware vExpert, and more recently, he worked in the Microsoft Azure Data SQL Server engineering team as a principal project manager in the Tiger team. When he's not grilling, he's working closely with customers all around the world to make sure they don't have to worry much about their infrastructure of data. And without further ado, here is the one and only Argenis Fernandez. Argenis, please take it away.
Thanks, Eric. I appreciate that. Guys, so today's session is actually jam-packed with tons of information. The main focus obviously is high availability and disaster recovery for SQL Server. Obviously, if you're playing along with Bingo, you kind of have to pay attention to the slides because we have lots and lots and lots of keywords and things that you will want to keep track of as you play along. But this is the agenda and the topics that we're going to be discussing today. RTO and RPO, it's kind of fundamental to understand what those concepts mean and how you can actually get your business to tell you what they want. We will talk about the traditional techniques for maintaining high availability or recover from a disaster. So we'll go over backup and restore. We'll also talk about lock shipping. We'll talk about failover cluster instances. We will talk about availability groups, and we will talk about big data clusters. But more importantly, we are going to be talking about how Pure can help you with all of these different scenarios and all of these different technologies, and how you have Pure powered alternatives to all of these things that allow you to go to achieve the same high availability and the same recoverability for your systems without having to rely on SQL Server intrinsic features. Or how do you mix it too? Right, because it's not all about replacing things or anything like that. You definitely can have things coexist. But this is more about get you guys thinking on what is possible out there with Pure technology. So here's the slide with the basic concepts I want to go over here. HA stands for high availability. DR stands for disaster recovery, and so the RTO, right, it's a basic concept for high availability, means the recovery time objective, and this is effectively how long the system can be unavailable. What is the maximum time that you can withstand being down for? And this is typically measured in seconds or minutes. If sometimes it's actually okay to be down for hours, but that's becoming less of a common occurrence out there. So effectively, what is the maximum time that you can withstand a failure? How long can you be down for? That's what RTO means. RPO stands for recovery point objective, and that effectively says how much data can I lose upon a failure. And then you have to start remembering that upon every failure event, upon any given system crash, you may lose some data. What data is it that's being lost upon a failure of a system? How much data can your business actually withstand losing? Sometimes you have to have an honest conversation with your business and ask them what is the supported RTO, what is what is an acceptable RTO, and what is also an acceptable RPO. If you just ask them, what the first time you talk to anyone in your business about RTOs and RPOs, it's just going to say 0, right? They want no downtime and they don't want to lose any data whatsoever. And we all kind of know that that's unrealistic, right? We know that there's going to be some downtime, right? It can be measured in seconds. If you do the right things, you can definitely be down for very, very, very little time. Talking about SQL Server instances here, right? We're talking about in the context of SQL Server. And then the RPO simply means of 0 means that you're not losing any data whatsoever. Do you guys think that's even possible with SQL Server? Well, there are some scenarios where you can definitely minimize data loss, but there are some things that are not quite going to be saved, right, upon a system failure. And that's also important to understand. Context around how your system is architected and how it all works together is important when it comes to RTO, with RTO and RPOs. So let's talk about backup and restores, right? It's a classic means of protecting your database. Backups and restores are what I call full on size of data operations, right? And what I mean by full on size of data operations, I mean have to go through the entire data set. Okay, and however big that data set is, I'm going to take that much time to complete that. So let's think about a 20 terabyte database, right? Which is not uncommon out there. If I needed to back up a 20 terabyte database, right, I have to read my entire database, all of it. And not only am I going to read my data files, but I'm also going to read a portion of the transaction log, because full backups do include transaction log backups. Just FYI, there's a portion of transaction log backups saved within a full backup itself, right? So you have to read the entire data set, all of it. All 20 terabytes are going to be read. Now, maybe not all 20 terabytes are going to be written to the backup device because you're using things like compression, right? And if you use compression, you're effectively reducing the amount of data that you're actually laying down on the storage device that you're backing up to. But that's also size of data operation, meaning you're still writing down all the data. It may be compressed, but you're still doing a full-on size of data operation. And so for a given backup operation, you're going over the entire data set once when you read it from your database files, and write once as another time as you write it down to your backup device. So that's two size of data operations. And obviously, the bigger the database, the longer it's going to take to back up, right? It's definitely not going to take the same time to back up a 1 gig database as it does a 1 terabyte database, right? Because you're talking completely different sizes of data. There's also the possibility that you may be looking at potentially asymmetrical backup and restore times. And what I mean by that is the time that it takes you to take the backup and lay it down on your backup device may not be the same time that it takes you to restore that backup, that backup that's laying on that restored on that device and lay down on the storage device that you read it from, where your data files originally were laid out, because you're performing a restore, right? And this can be due to a lot of different factors. The typical things that you see out there is that you're using some backup device that does deduplication and compression and ingests data really, really, really fast, but it's not so good at providing that data back. And so that becomes a bit of a problem, right? Because you definitely want to make sure that your backups complete in a given amount of time, right? And they're fast, and you don't spend forever just to complete one backup, because the longer your backup takes, you're affecting a lot of things around your system, right? You're imposing load on your storage subsystem, et cetera, et cetera. But the key proposition is if you can restore at least as fast as you backed up, it's kind of a problem, because now you have to take into account however much longer it takes you to restore that database. And so you really have to test these scenarios when you're looking at any backup device. How long does it take me to back up, but also how long does it take me to restore? And if not only do you test with one backup files and see, or multiple backup files, etc., but throwing a lot of backups at those devices and see how it behaves with a ton of data in them, because you want to kind of understand that behavior. So we have a little bit of a conundrum here, because if your database is extremely large, even if you're using local storage, local DAS SSDs, or Optane drives and things like that give you tons of throughput, you're still gonna have to get that backup out, to another box, and restoring that backup means going over the network, and that means potentially a bottleneck, right? So, how about you don't have to do any of that, right? How about you complement that backup strategy with snapshots? And so, storage snapshots, they come in two flavors, right? The first flavor is the app consistent snapshots, or also known as app aware snapshots. And the other ones are the regular snapshots that you take on the storage side. They're just called crash consistent snapshots. I just call those snapshots, right? The idea being, if you want to avoid the full-on size of data operation that the backup entails, remember there's two of them, right? One for the read, one for the write. If you want to avoid all of that, you can just snapshot your storage underneath the hood for where your database resides. And you can just recover all of that in a matter of seconds, because there is no size of data operation whatsoever, right? If you wanted to recover a snapshot from Pure, all you have to do is offline your database in Windows. The database may not even be available. At that point, just make it up, bring it offline, bring offline the volume where it resides, overwrite the volume with the previous version of it, as it was saved on the snapshot, and then bring everything back up. That operation on itself can just take a few seconds. Right? And that's effectively how long you will be down for if you needed to recover the entire database. Right? And so one thing that's also important to understand is once you take a snapshot, that data can be immediately streamed out to another storage device. Right? We support offloading snapshots. So you take a snapshot on flash array and then immediately starts being replicated over to another flash array, or maybe offload it to a flash blade, or maybe even send it to the cloud if you want to save it to an S3 target, for example. Right? So we have all of those different scenarios available to you. But something that is super important and super interesting is if you ever get owned by ransomware, and this happens more frequently than not, trust me on that one. We have customers that have been hit by ransomware, some of them more than once. If you take a snapshot, we can give you capabilities of immediately protecting that snapshot in the storage array, so that even if somebody takes over your entire infrastructure, including domain controllers, including credentials to your storage array, right? Because they have access, or maybe not to the credentials to the storage array, but even in that case, if they have and even if they have access to the actual file systems where your backups reside or where your database files reside, once you eliminate the thread, right? You remove all the attack vector from your network and are ready to recover. You can just recover everything from snapshots and bring your entire infrastructure back online from snaps. And this doesn't just work on the block side, right? When we're talking about devices that are seen by the SQL Server to be used for your databases, it also works for your file systems. So even the file system where your backup reside, which could be in a flash blade, for example, you can create snapshots that we call safe and created in safe mode, right? And you wouldn't even be able to delete those yourself unless you call peer support, because that's intentional. You have that two key mechanism to be able to delete something completely from the array, and that safeguards your data even from a ransomware attack. Right? And that's the ultimate protection that you can get. Not only your data is protected immediately, but it's also safeguarded from ransomware immediately. And so if you ever have to recover, you can recover all of it in a matter of seconds without even thinking about it twice, because you have that data safeguarded there, and it's always going to be there because the ransomware cannot get rid of it. And furthermore, it cannot encrypt it even if it wanted to. So that's an interesting proposition, right? Let me go back to that discussion around application consistent snapshots versus regular snapshots. App-aware snapshots are those taken by the VSS framework within SQL Server or within Windows. That includes a portion of SQL Server, the SQL Server engine called the SQL Writer. Okay, so when you want to take an app-aware snapshot, you need a requester, and this requester could be, I don't know, something like Commvault or NetBackup, or maybe you're using our SSMS extension, which is free, by the way. And then you tell Windows, hey, I want to take a snapshot of this resource that's a database. And then Windows says, hey, is there anyone listening for this resource called database 1? And the SQL Writer says, yep, I'm listening for it. I'm listening for it. These are all the volumes that are involved in that operation. I'm going to flush all IO buffers. I'm going to checkpoint the database, and then I'm going to quiesce IO against all the volumes that are involved in that database. When that happens, your database is effectively down. That's just the way it works. It causes a blip in performance on your database. It may be a second. It may be extremely low, an amount of time that it's extremely low, but you know what? You're still down. Even for that second, there are no queries that are going to be effectively succeeding during that time. And that's just because all the volumes where your database resides have to be quiesced in order to take an app-aware snapshot. This is just how VSS works. When VSS, by the way, once the volumes are quiesced, that's when our VSS hardware hardware provider gets called, and that just issues a snapshot against the array side, on the storage array side, on the pure side. And that takes nothing, it takes a millisecond or so to complete. Then IO can be thawed and processing can continue. But you see how this actually becomes a little bit of a problem. When you want to take that app-aware snapshot, you are going to be incurring into that little blip, and that little blip can affect the SLAs of queries running continuously on your system. So that's important to understand. The other kinds of snapshots that don't do any of this are what we call the crash consistent snapshots. I really just call them snapshots because on Pure, they do work all the time. And then the concept is you put all the volumes that belong to your database in what we call a protection group. right? And that protection group is kind of like a consistency group, right? So it enables you to take snapshots of all those volumes exactly at the same time and atomically. So if without any writes being missed, right, that they may be sitting in the ether, without any write ordering problems or anything like that, we take the snapshot of all those volumes together, and then we can actually immediately replicate that protection group snapshot to another flash array, or maybe a cloud block store in the cloud. It could be living in AWS or soon to be GA in Azure as well. So if you start thinking about all these things, Appleware snapshots give you only really one thing. They give you point-in-time recovery at the database level, so that you can restore an Appleware snapshot with no recovery and then roll forward transaction logs on top of that. But if you really don't need that, you can just take snapshots on the array side, right? The regular snapshots are a protection group scheduled snapshots on the array side. SQL Server doesn't know anything about them. Windows doesn't know anything about them. They continue to be taken in the background, and they always work. They always come on. They provide a version of your database that will always come online. And so that's cool, because you don't actually have the sort of nasty effect of time that VSS can create when taking that snapshot. Now, you can have all three models working together, right? You can have an Appleware snapshot that you only take during a maintenance window when you can actually withstand that blip of I/O when that happens. You can take crash consistent snapshots on the array all day, right? You set them on a schedule and the array takes care of that. And in addition to that, you can take your streaming backups, right? If you want to kind of complement your regular native backups with snapshots, I will claim that my native backup strategy is going to be my last plan of resort, right? If I cannot recover my database through a non-size of data operation method, like a snapshot, then I will look into restoring a backup. But I'm not saying that snapshots replace backups altogether, although they can if you do two things. You replicate those snapshots to another device that sits on a different data center, completely altogether different data center, because if it's the same data center and your data center goes up in flames, there goes your data, right? Geographically dispersed data center, number one requirement. Number two requirement is that you test them. Okay, so not only do you replicate the data, but you also light up the data on the target device that you're replicating to, and you run your consistency checks against those. So that actually is a good idea for you to understand whether your databases have any sort of corruption whatsoever. And we have capabilities on the flash array side that allow you exactly to do that, right? Clone the database that's being replicated into a volume that can be presented to a SQL Server instance on the target data center, light up a CheckDB against it, no problem. Okay, so I've been talking about backup and restore for long enough. So remember, backups and restores, you can have an alternative in pure snapshots. Now, log shipping is another oldie but goodie, right? It ships transaction log backups from one instance to the other. It allows for standby and read-only queries, allows for point-in-time recovery of your database, right? It allows for a time delay that effectively offers a window into how your database looked at a certain time ago. We have an alternative in the protection groups that I mentioned before, right? The protection group snapshots contain that image of your database, and you can have asynchronous replication of those snapshots going against another array. And what shows up on the target array side is a set of photographs of your volumes as they were at given times, okay, with that given interval of replication. You can always say, I want an ad hoc photo of these volumes to be sent across immediately if you wanted to, right? Or would you just want to keep, certain markers for certain indications? For example, NO quarter. I just finished my NO quarter processing. I want to take a snapshot at that time, and I want to have that replicated and tagged in a particular way so that I understand that I have a copy of my database exactly as it was as of NO quarter. So that's an interesting proposition. Log shipping, though, log shipping always goes forward in time, right? There is really not an easy way for you to like go back to whatever happened in 2 hours ago, because you have already rolled the database forward with transaction logs, unless you indicate that you want a time delay, right? If your transaction logs are newer than 2 hours, for example, you won't apply them. You will keep your log ship database as it was 2 hours ago. But if you need to recover it, then you need to roll forward all those 2 hours worth of transaction logs, and that can take a significant amount of time, depending on how busy your database is. The point is that with asynchronous replication on the array side, you have non-size of data operation snapshots I can recover immediately, and you can go back and forth at any point in time that you want. For example, if you lost data 23 hours ago, and something happened and you started overwriting the database, and you had some data condition there that you wanted to really understand what you really want to understand what happened there, you can go back in time and find that snapshot that contained the good data, light up the database as it was at that time, and then do whatever investigation needs to take place. Right? So this is actually very common to see in financial institutions, where understanding the progression of a data problem is important, right? And log shipping really doesn't give you that quick mechanism for rolling forward and back the database. It's much easier to just have multiple snapshots mounted as different database names and start looking at all the differences between them. And we enable that because flash array is actually a data reducing array. So all of those copies only consume the space, the reduced version of the space allocated in between or used in between the copies, right, in between the snapshots. And so that is as efficient as it gets from the storage side. So it's an interesting proposition here as well to have, I'm not saying you should replace log shipping with pure storage replication. I'm saying that you have a good alternative, potentially an entire replacement of log shipping using pure storage snapshots. More use cases. One that it's very common to see out there is test upgrades, right? You can't really test an upgrade on a log shipped copy, right? Because you have to turn down log shipping after you upgrade the target database. Because your shipping transaction log, once you have brought the database online on the other side, you have effectively upgraded the database, and you cannot apply any more transaction logs to that anymore. That's kind of a limitation of SQL Server and how it works underneath the hood, but that doesn't happen with pure snapshots, right? You can just have those snapshots being replicated, take one of them and say, you know what, this is actually going to be my upgraded version of the database. I'm gonna go run my upgrade process on that one copy, and I can continue having those copies of the data being served by that previous version of SQL Server if I ever needed to, right? You're not limited to an all or nothing proposition. This is how useful storage data services are on the array side. If you wanted to offload tasks, this is a very common proposition for a replication snapshots as well. The typical scenario is, oh, I want to just offload CheckDB out of my main database. You can do that within the same array, right? Clone your database, run CheckDB on that, no problem. But if you wanted to replicate a snapshot of your database and then run CheckDB, offload CheckDB completely on another storage device, on another flash array, you can totally do that. And there's a ton more use cases around that. For example, let me update stats on this massive multi-terabyte table. Doing that in production may actually be a little bit of a pain, right? Because you're going to be causing potentially a lot of queries to not behave very well when you do that. Well, you know what you can do on Pure? You can just clone your database, and then maybe on the same array or replicate its snapshot to another array. You can just update stats on that target array and then script out the stats blob once you're finished with that, and then apply it to your production database. Right? So that's an interesting use case and another a set of our customers use as well. And so just start thinking about how this technology can fuel all these different use cases for you. All right, so let's keep digging into the different use cases. We're going with failover cluster instances now. Now, this is a model where you're sharing everything. Right? Your storage is seen by nodes, right? And these nodes fail over SQL Server.exe and effectively look at the storage underneath the hood and light up the databases contained within that storage. Now, one thing that is difficult to achieve with failover cluster instances is high availability at the storage side. Right? If you have a single copy of your data, like it works on an FCI, then if you're doing anything related to the storage side, you lose your storage for whatever reason, then it becomes a little bit of a pain to provide that high availability to the business. What you can do is have array replication, right? Maybe within the same data center, or maybe stretched across to a data center, as long as the constraints on latency are met. And you can have multiple copies of your data powered by what we call pure active cluster. And that is what we call a stretch cluster, right? So you have a version of your cluster on one data center and a version of a cluster on another. And you can actually do synchronous replication between the two we support up to 11 milliseconds of latency between the two arrays. And in that case, when you're using active cluster, every single thing that you write to one storage device will be synchronously replicated to another device. Your workload will feel the latency introduced in there. But if it's kept within the same data center, you will always keep that latency under 1 millisecond, and that won't be much of a problem. If you're stretched across links that are lengthier, and latency starts becoming a problem for your workload, what you can do is protect that workload with what we call active DR, which is basically asynchronous replication of writes issued against one storage device. So write comes in on one device, gets asynchronously replicated to the other device. They get basically journaled and sent on a continuous stream to the other device. So there is a delay effectively from one array to the other. With active cluster, there is no delay, meaning there is no data loss whatsoever, right? Whatever you write here will be reflected here. With active DR, your RPO can be a minimal amount of seconds, right? So we keep it as close to 0 as possible, but there can be a few seconds of delay in there. It's typically under typically 5 seconds or less of delay between arrays that are replicating asynchronously. So your storage upgrades always maintain the high availability of your database with pure storage. But if you ever suffer a failure of any sort around the storage network, for example, with active cluster or active DR, you can actually provide high availability for your database. So you no longer have a single point of failure there. Let's talk a little bit more about another HA and DR technology that's more modern, right? Availability groups. So there are two flavors of availability groups, right? You have availability groups using synchronous replicas, and you have availability groups using asynchronous replicas. And so they work very much. Yes, go ahead.
Sorry, we have a question. The question is, I have active DR on my card. I think it should be active DR.
I'm sorry, can you say that again?
Somebody says they think they have active oh, never mind. I think it's a bingo question. Never mind.
Okay, all right, no problem.
Sorry.
I'll move on to the availability groups slide now. So AGs, right? It's how we affectionately call them. They have synchronous replicas, right? Those that actually don't acknowledge a transaction as completed until it has actually hardened on the target replica. You can have multiple sync replicas these days, or you can use async replicas. In that case, async replicas means whatever is being written to the primary replica will eventually make it to those asynchronous replicas, and those replicas can be delayed significantly. There are several problems with availability group typically, but one of the main problems is seeding availability group replicas, because that means a full-on slice of data operation, right? It's a full-on restore. And how you do that matters actually. If you're using a traditional restore, you're not affecting log transport, meaning you're not taking the same channel that's being used for replicating your transactions. Because if you use auto seeding, you're definitely using log transport, and that will potentially cause some performance issues as you seed those availability group replicas with auto seeding. So either auto seeding or restores are basically your ways of seeding your replicas. And so what you can do seeding with Pure is they're interesting. There are really two models for seeding availability group replicas. If you're using test and def availability groups, one thing you can do is take a snapshot of your primary replica and then seed all the replicas based on that snapshot. But to do that, there are tricks that you need to follow. Right, so the main trick on seeding availability group replicas with a snapshot from Pure means you would have to create a shell database, right? That is that has all the files that you need for your availability group database, and using the same file IDs, etc. But it's an empty database, right? So what you do is that you script out the source database that you want to seed. You create a shell database with the final database name that you want for your AG. You have auto seeding of that shell database, right? It's going to be a tiny database, so it's not going to take very long. Then you offline your availability group, right? All of your entire set of SQL Server instances, and then you take a snapshot of the actual database that you want to seed, not the shell database, and you overwrite all the shell databases with that database that you want to now have it become an AG or from the replica that you want to create. And so what that does is that it eliminates the need for a size of data operation altogether when it comes to seeding the AGs. Right? You can take, it doesn't matter the size of the database either. It doesn't matter if your AG replicas are spread across multiple arrays. This is totally fine, or even across multiple data centers, because you can always tie in protection groups and a synchronous replication of our protection groups with this technology as well. So what you do is that you just refresh everything and bring your AG online. And the reason why this works really is because your data files will all be synced at the same time, and your transaction logs will all be the same, effectively just kickstarting your AG from the same LSN or log sequence number. And so that's a nifty trick that we use. Some of our customers use for test and dev environments. If you wanted to seed an availability group replica from in production without taking any downtime, you would use our SSMS extension, or what we call the PowerShell Backup SDK. With that, you will be taking an app-aware snapshot of your primary replica, right? You would have that snapshot, maybe replicate it to another array, or maybe use it on the same array, and then you would restore that snapshot with no recovery, so that you can then tell the AG, hey, this database is ready to go. You may have to apply some transaction log backups after you restore the snapshot, just to catch up the database there if the log has moved on significantly. But typically you wouldn't need to if you just took that snapshot and just restored it. Or maybe if you don't want to take apply that much transaction log or those many transaction log backups to that replica, you just take a differential backup on your primary replica, and then apply that to your secondary replica that's sitting there with no recovery, and then tell the AG to add that replica or bring it online as part of the AG. So you see how the two methods basically avoid a size of data operation altogether. None of them consume any log transport capacity whatsoever, and it doesn't matter what your size of your database is, right? All of these things you can do seamlessly. One thing that you want to keep in mind is pure storage flash array is a data reducing array. When you're replicating data across arrays, we'll actually ask the target array, have you seen this piece of data before? And that's important because if you want to minimize the amount of data that flows across arrays, if it actually has seen a piece of data before, you don't need to send it again. And so that keeps things reasonable and very efficient when it comes to replicating data. All right, so we'll pause here because I know what I mentioned here is actually kind of interesting, and I will make a couple more comments after I query for any questions. None thus far?
Hi, Argenis. Yeah, no questions so far. Questions have been about the bingo. We've actually had one bingo winner so far. So wow. Yeah, I'll keep you posted with any questions.
Okay. All right, that's pretty cool. All right, so we talked about seeding availability group replicas with pure power snapshots. Extremely powerful technology. But there's also the possibility of you replacing some functionality from the availability group by using our replication technology. Now, consider that availability groups do very interesting things like having a listener, right? Where your listener fails over automatically, and your database just follows that listener name, and your application follows that listener name in your environment and starts sending queries to that listener, regardless of what's happening underneath the hood with the actual availability group. Your listener stays up, right? But if all you really need to do is synchronously keep data safeguarded across storage devices and have a copy of your data that entails zero data loss, well, you can just use ActiveDR, right? And active cluster, and that's a synchronous replication technology that can still keep your storage latency significantly low, and that's actually faster than availability groups in sync mode, right? When you do sync mode, sync replicas, you will incur into latency penalty as well because you're replicating to another replica, to that other replica, or maybe multiple replicas, and you would actually have to wait until that replica hardens the I/O locally, and then finally, there's an acknowledgement back that log was actually hardened on the other side before the primary replica can move on. So it works pretty much the same way on the active cluster side, right? When we synchronously write IOs, again, we're waiting for the target array to acknowledge the completion of that IO, but we're not cracking open structures, right? We're not looking to see what is it that we actually need to replicate or not. Things happen at a higher level of throughput and a lower layer of latency than it does on the availability group side. So if this is a problem for you, where your AG is actually introducing synchronous AGs is introducing are introducing latency into your workload that is not acceptable, you may want to look into leveraging something like Active Cluster. So again, I'm not saying that availability groups is something you should get rid of. I'm saying that there are alternatives that potentially can give you better latency and better throughput. The other case of availability groups is async replicas, right? When you have an async replica, you're not really waiting for that replica to acknowledge IO before you move on the primary, but you're still limited to whatever throughput the availability group can give you. And so we have noticed from tons of customers that have very large databases that when you do things like re-indexing a database, rebuilding an index, that can cause a lot of backing up of queuing on the availability group on the primary side, because it has to send all this log blocks over to the replicas. And the replicas have to redo these blocks constantly, right? An alternative to that will be to leverage ActiveDR, right? With ActiveDR, you can achieve multi-gigabyte per second performance on the throughput side and keep the RPO extremely low and send that continuous stream of data. And so those index rebuilds, so those modifications underneath the hood, will just be sent across and replicated at the block level, rather than go log by log, block by log block, and replicate those over to the async replica. So that's an interesting proposition. Again, I'm not saying that you should get rid of your async replicas using availability groups, but if this is a problem for you, you may want to look into leveraging these mechanisms. All right. And so finally, we have big data clusters, which is the newest SQL Server technology from Microsoft. For data protection of big data clusters, we have a technology that can help you protect your Kubernetes cluster that powers your big data cluster. That technology is called Portworx. And so that's a new technology that we just talked about recently here at Pure. And that has PX Backup as one of the products that they offer. That can help you back up your entire BDC infrastructure seamlessly, and that can offer significant gains and a significant level of protection for your big data clusters. So if you're interested in learning more about Portworx, please feel free to reach out, and we'll be happy to give you tons of information on that. The other thing you can do, in addition to protecting your Kubernetes cluster with Portworx, is to use flash array or flash break snapshots to recover instantaneously from any scenario, including ransomware, again, on the big data cluster side. It doesn't matter if you're running Windows or you're running Linux, your crypto locker is not going to care what operating system you use. It will want to lock every single volume regardless of whatever operating system you run. And so one of the things that you can do using our technology is to replicate data between an on-prem big data cluster and a big data cluster in the cloud using Pure's technology. So those are some of the ideas that we want to get into people's heads when it comes to big data clusters and data protection. And I think that's all I had. So I'm just going to go ahead and pause here to see if there are any questions. And I believe a lot of you guys have been playing along for the mingle, so I hope we have plenty of winners so far.
Hey, Argenis. So far we don't have any questions. Again, all the questions that we've been having is about the how to introduce the code. We do have a couple winners so far. I mean, depending on verification that their bingo card is a valid one. But so far, we do not have any questions. Now, while everyone is, sorting out their cards and coming up with their questions, I did wanted to remind you, please, after the session ends, we'll have an evaluation for you to fill out to provide feedback for Argenis and for PAS. So we would really appreciate if you could fill that form out. Argenis, do you have anything additional to add?
I just wanted to thank everyone for their time and coming today, and attending this presentation. And if they have any questions or want to reach out and understand more about the things that we talked about today, you can reach out to myself on Twitter at dbargenis or argenis@peerstorage.com, or you can just reach out on to our sales teams at sales@peerstorage.com.
Amazing. And for those who might be wondering about the slides, we'll be uploading the slides where you'll find the recording, so don't worry, we'll have a copy for you. We didn't upload it this time because, of course, the words, you could have find some words in there for your bingo card, but we'll definitely make sure to share those slides with you after the webinar, along with the recording. We do have just a quick message from Heather. This was a great presentation. Thank you so much, Argenis. Yeah, we just keep on having a lot of people here submitting their bingo cards. I think we're just gonna leave a couple minutes for those who are finishing up with their bingo cards for them to submit. But I guess if we don't have any more questions, I think that will be it.
Great, thank you so much, Eric. This is Carol, everyone, and thank you all for playing along with the bingo. We do have a few winners, and we'll, like Eric said, we'll get those verified and get those prizes out to you. And if we find that we have a couple extra prizes, what we will do is we will do a random drawing from all of the people that were in attendance today if we have some extra prizes. So you may be surprised and get a prize after all. So thank you all for attending.
Yes. Thank you, Andy. Thank you, Anil. Thank you, Rune, Keith, everyone that tuned in and was playing along. Good luck and thank you for tuning. Argenis, on behalf of PAS HQ and everyone down here, thank you so much for today's presentation. It was great content. And yeah, I think that would be all.
All right. Thanks, everyone.
Thank you.